Hi everyone, my name is Aaron and I'm here today to talk to you all a little bit about high availability and how we can implement high availability with SQL servers. Welcome, come in, sit down. I have a little bit of a confession to make. I do not have a database background, so I feel like everything's a bit new, and many of you will probably know far more about working with databases than I do. My background has been more on the infrastructure side, and particularly around high availability and load balancing, in which I've worked for the last 13, 14 years. So I'm now with SIOS, which specializes in HA and does an awful lot of database work. So hopefully today I can demystify a little bit about providing HA for SQL Server, and also explain a little bit where SIOS as a vendor can fit into that as a whole. So let's get on to my first slide here. So I've got a couple of bullet points here, the definition and the importance, so we can talk about exactly what HA really means. Keeping it simple, high availability is really about making mission-critical applications and services not break. I've got better words on the slide there that you can see, but it really boils down to having a system that can withstand a failure. Now, the importance of that, I think, for any critical system in your environment, in your company, is becoming more and more important that these things are HA. It's now pretty much expected. People require things to actually work, and for example, if your favorite social media site is down, people will soon know about it, and you'll find that people miss these things, let alone more critical applications such as your SAP environment within your company, or maybe something important such as medical imaging. Now, I have a very, very simple diagram here, just basically showing a couple of nodes, a primary node, a redundant node, and failover is represented at the top by the dashed arrow between the two nodes. And we also see a simple shared storage solution at the bottom there, which is typical of a sort of two-node active-passive cluster. Now, looking at that diagram, I mentioned the shared storage at the bottom. Typically, you're going to need shared storage, shared data between your applications in order for failover to occur, so that when the client access protocols and the actual SQL Server application itself fails from the primary node to the redundant node, it's going to get to see the same back-end data and be able to serve that up. Typically, in a lot of environments, that's going to be quite expensive storage, something like a SAN. It might be a cloud solution, which also can usually get quite expensive as well. And typically underneath that, you're going to have data protection provided by something simple like RAID, which, while good at protecting your data, does have downsides in terms of maintenance, changing disks, reinitializing the RAID, and things like that. So it's HA, but it's not guaranteed that you can withstand a failure and continue working. I briefly wanted to take a little segue into HA in the real world, and due to our theme today being around aviation, I thought it's a great opportunity to kind of call that out. In the world of passenger aircraft, there's a lot of regulation about being able to withstand an engine failure. You're expected to be able to set off, have a failure, and still be able to arrive at your destination even on a single engine. And I think this is very much how we need to approach IT today. Things need to function even though things might break. So with that in mind, what HA options do we actually have? Now, I drew this little diagram on the right-hand side there. I'm quite new to SIOS, and it was something that I wanted to do to sort of, in my head, sort out the different types of HA that we're covering. And you've got the application and the data. So my background, coming from a load balancing vendor, I'm used to dealing with application HA. And there's many forms of doing that: clustering software, load balancing, and DNS, so GSLB type solutions, Route 53 and Amazon, that sort of stuff, where you've actually got health checking and the ability to pull a server should it fail its health check and switch it out. Now, clustering is typically going to be 2-node clusters and is your belt and braces for HA. Load balancing tends to come into play when you're wanting to build scale, so you're scaling it out. But it also has the ability to run health checks and pull nodes out of service should they fail. However, load balancing doesn't get down into the data level whatsoever. It's usually front-end application, typically suits the sort of application where it's not stateful. So the other thing to bear in mind, just because I mentioned it earlier, was DNS, which is a perfectly reasonable solution. Route 53 is a great example of that. But DNS has some downsides too. Results can be cached, failover can be slow, and also different users might find that failover is different depending on what DNS servers they're using, what the different caching settings are set, from their upstream DNS server. So generally what I find is that clustering is going to give you the fastest guaranteed failover. And for a system like a SQL database, it's usually more than enough. Now, below the line, we get into the data side of the HA. So typically, you're going to have something like shared storage, like a SAN, and we discussed that earlier on. Another solution might be block-level mirroring. So that's when you're mirroring from one disk to another disk. And I'll get into this more later, but with our solution, you're actually able to mirror from a local storage on one node to local storage on another node, so that when you actually fail over, that the data is going to be there and available. Some final point that I mentioned there is simple data replication. So this might be something as simple as using rsync for those that come from a Linux background to synchronize the data from one location to another. Or it might be something more complicated than that or specific. For example, log shipping. You can ship your logs up to another server and then you can replay those logs into the server to actually replicate that data across. Although, again, a bit like DNS, there's some downsides to that. It's not true HA. It's almost leaning towards more of a backup solution. So this gets me into my favorite part of HA, which is the number of nines that people like to throw around a lot. So we've got a chart here. It's actually quite a nice chart, actually. And it shows the different levels of HA that you can achieve there on the left. And some of the applications that might achieve that HA on the right. And we also show there the number of nines, which a lot of people, as I say, will band around. Now, you're looking at the bottom, infrastructure availability. So this is just basic level of availability. It's more than no reliability whatsoever, 0%. It's going to give you 2 nines, as people would typically say, 99% availability. We then move up to just availability there on the chart, and you can see here that we're now having things like automatic application restart being in there, and also specifics like VMware has a certain amount of HA built in, and so does a lot of sort of infrastructure like clouds and things like that. So we can get up to the 3 nines, 99.9% available. From there, we usually get into more complicated systems. So clustering is probably the simplest. You might be talking about load balancing as well at the sort of 4 nines availability. So again, that's going to cost you more to achieve as it goes up the chart, but is going to give you a much better reliability, because when you're getting into clustering, you're having more than one of everything. You've got more than one server. You've got more than one of the whole setup in theory, so you can cleverly fail it over with minimal disruption. And we mentioned briefly the 5 nines at the top there, which is continuous availability. And at that stage, you're getting into full system fault tolerance, which is very much a different thing and comes with horrendous pricing. One last thing I wanted to mention on that slide, which I think is very, very useful. Just coming from a load balancing background, people throw the nines around an awful lot, but we actually show there how much downtime you can expect. And I think that's something that people don't always consider. So if you're looking at a solution, for example, that's 99% available, That's potentially 3.65 days of downtime a year, unplanned, which is actually quite high when you think about it. 3 nines, we move up to 8.76 hours, which again is quite a lot if you're thinking about that as unplanned. And then often, as I've suggested, the sweet spot is around the high availability mark, where you're seeing 52.5 minutes per year. We get to continuous availability and we're down to 5 minutes, which I think is incredible. And you can see why that sort of level of protection is going to cost you a lot of money to achieve. So I want to bring it back now to SQL servers. So we've talked a little bit about HA and the different types and the nines. But how does this apply to SQL servers, and how does it also apply to your business? So I've got a few bullet points here. It minimizes downtime. So high availability configurations will help minimize downtime because they provide mechanisms for automatic failover. We've got business continuity. Now, I'll say this, HA is just one component of achieving business continuity. It is not going to solve all of your problems, but by, again, helping people to maintain access to their critical applications and data, we're helping to improve their business continuity. Meeting service level agreements, so SLAs. Many organizations have SLAs that define the acceptable level of system access and what downtime that they can actually withstand. And, HA is going to help you achieve those SLAs within your organization. Something I've come across before a lot, regulatory compliance, finance, healthcare. Some of these industries have their own compliance and effectively SLAs that come from that industry itself that you've got to maintain. And they can have punishment should you not achieve them. So it's quite important if you work in those industries to make sure that you're actually keeping up with the regulatory compliance. And just finally, customer satisfaction. So having uninterrupted access to your data and applications by providing HA contributes to your customer satisfaction level. And I think that for any business that provides a service, such as e-commerce platforms or other things like that, you're going to want to build trust with your customers and help retain customers. So having uptime and a service that actually works is very, very important to that as well. So bringing this back now to SQL Server, and specifically Microsoft SQL Server, we have a few options at our disposal here. So we have, I'm sure many of you have come across this stuff before. We have failover clustering instances, so FCI as it's known, and our solution can work with that in order to provide a HA active-passive cluster. And then we have, so that tends to work at the instance level, which is why I've separated that out, because it's everything is being moved over. And then we have sort of more database level HA. We've got log shipping, which, as I explained, is a little more than backup, but still that direction. We have always on availability groups. Availability groups is extremely powerful in enterprise SQL Server and allows you to do all sorts of stuff, including scale. And you could use availability groups with your read replicas and potentially even a load balancer to spread your read workload. And then we have database mirroring, which is deprecated, although I believe it's come back in a sort of availability groups light version recently, but we won't get into that in great detail. Now, with all of these, again, we often need some kind of storage solution, especially with FCI, where we're not moving the database to all the different nodes like we are with availability groups. Instead, we're expecting some kind of shared storage solution. And that can come in the form, I'd say most typically it's going to be SAN-based storage. But more recently, they have started supporting Samba shares, which the IOPS must be terribly slow in some cases, so it's often not going to be good enough for your needs. So I wanted to just touch on, as I say, I'm new to SIOS, the company I represent, but I wanted to touch on what we do and what we do different. So we offer a product that ties into failover clustering and allows you to not only do the failover between the two, like you would normally with failover clustering, but also handles data replication. So in this scenario, you can use local storage, and you can use block-level data replication so that your data is permanently being synchronized over to the other node. So when the failover of the client access protocols, the IP addresses and things like that, and also the application, so SQL Server itself, moves from one node to the other, it can expect the data to be there locally. And that offers some benefits. It's a massive cost saving over something like SAN. It's going to be much more performant than something like Samba shares. And it also means that because you're not having to move over to availability groups, you can stay within the normal non-enterprise license. You can be on the standard license. Which brings me to this slide. So it just shows here the sort of cost savings that you can actually achieve by using something like SIOS Datakeeper, along with failover clustering and standard licensing versus having to move to the enterprise. Typically, we're going to see about a 70% saving by doing that. And out of interest, my colleague Harry's got a session tomorrow where he dives into all of the benefits of the cost of using us rather than moving to SQL Enterprise. However, I'm not going to delve too deep into that. I wanted to use the last moment or two really to mention that we also offer more than just the Datakeeper working with FCI. We have Datakeeper Cluster Edition, which of course the Datakeeper part can be on Linux or it can be on Windows, so you can have that same solution of replicating your local storage from one to another using Datakeeper for either. And in cases like where you're using, say, an open source database, maybe on a Linux machine, we also provide LifeKeeper, which actually does the job of failover clustering. So we'll actually move the application, start the application on the other node, we'll move the IP addresses and things like that over the client access protocols as well. And they're also cloud ready. So in the case of being in Amazon or Azure, we tie into things like using EIPs rather than just local IP addressing, load balancers, Route 53, and actually into the routing tables in some cases to be able to move IPs and maintain that client access. So that's kind of a quick rundown of HA, what options are available specifically for SQL Server, and what options that SIOS also offers. So, quick session as it's been. I'm going to throw that over to a Q&A now. So if there's any questions whatsoever, anything I can help demystify while I'm here, please feel free to fire away. Yes. I think with enough money maybe, so the question was about whether continuous availability, as shown a couple of slides ago, was actually really achievable in the real world, right? And I think it is if you throw enough money at it, but it's one of those things that you really have to do properly. It's not just a case of like a software clustering solution or a load balancer is going to give you that level. At that point, you're looking at quite specialist stuff that you're going to need to purchase and buy to make sure that not just the servers are available, but everything, the power to the building, you've really got to go overboard, and it's going to cost lots of money to achieve, if that answers your question. So any other questions? That's a very good question. So I'll repeat the question through the microphone, but basically availability groups will share the data so that each node has its own local version of the database, which has been synchronized across. Is at the database level rather than at the disk level itself. Now, what the question was, should there be a problem like disk corruption? Would that not be replicated across? And you're quite right, it can be. I mean, we are doing block level replication, so we're literally replicating at the disk level. Now, there are some things and some ways that you can help avoid this. I mean, if you're doing maintenance, for example, and you're worried that something might happen, you can pause the mirroring during that time so that you know that the server, you're upgrading, is not going to be synchronizing that data across until you're happy that it worked, and then you can re-enable the mirroring, restart, resume that process. But we're not here to protect your data. SIOS is a solution for replication. So the data itself, we're not checking it. We're not clever enough to actually understand beyond the block level what's going on, if that makes sense. Right, well, I think that's time now. So unless there's any other questions, thank you very much for your time today.